welcome to this video on T105 basic theory. So in this video we're looking at probability. Let's look at the question and then discuss some of the things that we're going to need to know. So a jar contains 4 yellow balls and 5 red balls. So we've got our contents here described to us. One ball is removed from the jar, then another ball is removed from the jar without putting the first ball back into the jar. And that's quite a key point here, that one of the balls isn't put back in the jar. So we want to find out what the probability is that both balls are red. And we've got a list of answers here, and we'll see if we can find the correct one. So let's go over some of the probability concepts. Let's read through this slide, and what we'll do is we'll use a simple example so we can see what kind of outcome this is going to give us. So what we can see here, probability is the degree of certainty that an event will occur. Probability is quantified as a number between 0 and 1. So what we're saying here is what we can see pretty much down here. A 0 is going to indicate impossibility, so it can never occur, and a 1 indicates certainty. So we can have any value in between here. Examples, you could just have 0.5. Any other value between 0 and 1 is completely fine. The higher probability of an event, the more certain we are that it will occur. So let's try and think of some events on the next slide to see if we can think of the probability of events. And let's try and use this formula that we're given down here. Probability that an event can occur, so a number between 0 and 1, is the number of times an event can occur over the total number of events that can occur. So if we consider some of the most common cases for probability, just to use as examples, let's first consider a coin toss. Okay, so in a coin toss what we have is we have two sides, heads and tails, and they're both equally likely to occur. So we know that just from general physicsy kind of stuff. And so using our formula on the previous slide, what we have is that the probability, so let's just call that P of coin, so the probability of a coin equals heads, is going to be equal to the number of times that event can happen. So let's say we're going to toss the coin once. That's the easiest case. So the number of times that event can happen is equal to 1. What are the possible total number of events that could occur? Well, the coin could either be heads or tails. So on the bottom we have 1 over 2. Okay, and so what we can see is we can convert this to a decimal, and that's equal to 0.5. So this is our probability of tossing a heads if we use a coin. So let's look at a second slightly more complex scenario. This is going to be the dice roll. So we've got a dice and it's got 6 sides, 1 to 6, so 1, 2, 3, 4, 5 and 6, and they're all equal probability of being landed. So let's calculate the probability of one of these sides being rolled. So we're going to roll the dice once and we're going to calculate the probability of a 1. So this just denotes the probability of a 1. So if we use our formula from before, the number of times the event can occur, well, we're rolling the dice once, so we're going to have 1 possible number of times that the event can occur. On the bottom of our fraction, what we want to do is look at the total number of events. So if we roll the dice, the total number of events is we can land on any of these 6 sides. So that's going to be a 6. And that's also equal to, in decimal form, 0.1667. But this is a recurring number. This is actually 0.16666 . 6 is going on forever. So sometimes it's more convenient actually to use either form. Both are acceptable, so you can either use the fractional form or the decimal form, where I've just rounded it off here using a 7 for convenience. So what we've done here is we've set up our problem from the previous example. So 5 red balls at the start and 4 yellow balls, and we said that when we remove a ball we don't replace it. So in this case, on this branch, the yellow ball has been taken, so we go from 4 yellow balls to 3 yellow balls, and the probability can be calculated of this branch. And of this branch here, a red ball has been taken as we go from 5 red balls to 4 red balls. So what we can see is all this diagram shows is our path opportunity. So we've got a 50-50, well, not a 50-50 chance, but we've got a chance of taking either branch. We've got a chance of taking this branch when we pick a yellow ball, or this branch when we take a red ball. We've got a chance of taking this branch when we take a yellow ball, or this branch when we take a red ball. So let's calculate the probability of taking both the red branches. So in the first case, what we do is we use our formula from the previous section. And what we can do is we can look at that and we can say, well, the probability of red, so let's go here, P, well, let's calculate it over here on the side. So in the first case, I'm going to call this 1, case 1. So 1, P of red. So if we use our formula from last time, well, if we take balls out of the bag, let's say we take all of the balls out of the bag, what's our probability of red going to be? Well, the number of times that an event can occur, well, that is going to be 5, because we have 5 red balls. And what is the total number of events that could occur? Let's have a look. Well, that's going to be 9, because that's the total number of events in this setup. So what we've got here is that this branch number 1, is going to equal to 5/9. What we've done is that we've then removed a red ball if we take this branch, because we know that we've taken a red ball. As you can see in this branch, we know that we've taken a yellow ball. So let's now move on to this second branch, which is the other route, the second route we have to take to pick another red ball. So number 2, the probability of red again, and that's going to equal to our 4 red balls, so 4 over our total number of possibilities, which is this time 8. So this is now equal to 1 over 2, and that's just a simple cancellation of the top and the bottom of the fraction. So this is very good. We've found out the probability of our first branch, we found the probability of our second branch of picking the red ball, and now what we need to do is calculate the total probability. So what is the overall probability? That's going to equal, let's call this R1 and R2. So P is going to equal to P of R1 times by P of R2. And we can do this very simply, and that's going to be 5 over 9 times by 1 over 2, which simplifies very nicely to 5 over 18. And we can just double check that with some of the previous answers on the slides and check that this is the correct solution. So here what we can see is the answer that we went through on the previous slide, just explained in words. So let's just go through some of the key points of this. So the probability that both red balls are picked is explained here. So the first stage is the first branch that we went through on the previous slide. And we have 4 yellow balls and 5 red balls. So the total number of balls in the jar is 9. And the probability that first ball is red is going to be the 5 red balls divided by the 9 here. So 5 over 9. And then the second red ball, well, since we know that the first ball is not put back into the jar, and we know that we have to have taken the red ball out, we're going to have 4 red balls in the jar. And the total number of balls in the jar is just going to be 8 now. So we can apply the same thought process that we did on the previous slide and to this part 1, and we find out that that's 4 over 8, which is 1 over 2. So the product of the two probabilities gives us the probability that both balls are red, and that's just calculated here in this statement, which we did on the previous slide. So we can see that, as we suggested, the answer is D. And let's just go through and recap a couple of the bits that we've learned from this section. We've learnt what the probability means, so we've learnt what our 0 all the way to 1 means, so 0 being completely impossible, 1 being completely certain, and we've learnt what that kind of is analogous to in the real world. We've also learnt how to go from a real world situation where we have balls of different colour in a bag, and we see how we propagate that to a probability when we're picking balls randomly from a bag.